Hello everyone, let's start with the problem Redstone, and it was asked in Codeforces Round 1044 for Division 2. So let's read out the problem. Steve stumbled upon a collection of n gears where gear of I has a of I teeth and he wants to arrange them into a row. After he arranges them, Steve will spin the leftmost gear at a speed of 1 revolution per second. For each of the other gears, let x be the number of teeth it has, y be the number of teeth of the gear of its left, and z be the speed the gear of its left spin at. Okay, then its speed will be y by x into z revolutions per second. So Steve considers the contraption satisfactory if the rightmost gear spins at speed 1 revolution per second. Determine whether Steve can rearrange the gears into a satisfactory contraption. So, okay, yeah, let's understand with the first example. They've given 5 examples. So, let me take one by one. So, in the first example, number of gears are 2 and they are 5 comma 5. Let's take an array. So what they are saying is that, let's say they have given these gears, and if you want to arrange in some order, in this case if you try to arrange, let's take first element and then second element, or if you want to take first second element then first element, both have the same arrangement since both the elements are same. So let's take only one case wherein we have this arrangement 5 comma 5. So in the question what they are given is the leftmost gear. Gear, I think you guys know, in the wheel there will be this kind of mechanical structure. So it has, in the first example they are saying it has 5 teeth, 1 2 3 4 5 teeth, and second gear also has 5 teeth and they are connected. 2 3 4 5. So in this way they are connected basically. You can think of. And what they're saying is the leftmost whatever is there, that will be rotated 1 revolutions per second. 1 revolution meaning in 1 second, so it will rotate only one time. So that they win. And what they're saying is if you try to stand at, let's say, this index, its speed will be given by now here one more catch is that number of teeth whatever is there, you will be taking x as number of the teeth, and the previous gear whatever it has, its teeth will be number of teeth as y, and it is rotating, let's say, at z speed. So it is given by y by x into z, the speed of this ith index gear. So let's say you are standing at ith index and the speed of that will be given by y by x into z. What is x here? As I said, x is basically the number of teeth it has, and x is x is that, y is basically the previous leftmost element, not leftmost from this current element. If this is I minus 1th element, so it has y number of teeth and it is rotating at z revolutions per seconds. Now this speed, let me call it as s. If you call this speed as x, and if you multiply this, it will be x into s is equal to y into z, right? So if you try to see, like, this is basically the number of teeth and this is basically a revolution per second, right? What is this? This is for index I minus 1th, and this is y is number of teeth and this is revolutions per second that you are going to find it, and this is for ith index. So if you try to see, since for every gear this is true, x into s, I mean number of teeth into its revolution, these multiplications are equal according to the question. So if they're equal, you can in generalize write it as number of teeth, let me call it as t, okay, into revolutions, let me call it as r. This is equal to some constants k, you can write, right? Because these two equations in mathematics, if you try to put it, you can put in this way: x into s is equal to some constant k, and y into z is equal to some constant k. So since RHS are equal, LHS can be equalized. So that is the condition. So from this, now you are driving as this is equal to this. I mean, number of this into relation is equals to k. Now, which means t is inversely proportional to r. You can write it proportionality, meaning if the revolution of the wheel increases, means number of teeth will be decreasing. If number of teeth revolutions is decreasing, so this revolution will be more, meaning I'll be telling, don't worry, this is just a mathematical, so I'll make you visualize also. So let's continue with the problem. You have you'll have to calculate if this is a valid arrangement or not, and last one will be rotating at one revolution per second. So if you since in the question themselves, first will be rotating at one revolution per second, so its speed will be one only. Now if you want to find the speed of this, you can put it as x by x into z. What is y here? Y is basically its previous teeth, and x is current teeth, and what is z? Z is previous revolution, I mean previous speed, which is 1. So this is giving you 1, so its speed is also 1. So 5 comma 5 is such arrangement that the rightmost gear whatever is there, that is rotating at 1 second, one revolution per second. So this is a valid arrangement, so you can write it as yes. But now in this case, since both were equal, and if you try to think of, you have one teeth, one gear, and one more gear you have, let's say. So both has 5 teeth. Now since both the sizes are equal, number of teeth are equal, so if it is rotating at one revolutions per second, then obviously this will also be rotating one revolution per second, right? That is true, and this is according to this also. Since here you have 5 teeth, revolution is 1, so and this is equals to, let's say, k, and your k value is 5 in this case, okay, some constant. Now let's say you remove this teeth, I mean gear, and it has, let's say, 10 teeth, 4 5 6 7 8 9 10. Let's say it has 10 teeth. So if you try to visualize, since this is rotating at 1 revolution per second and it has more of teeth, so this will be slow, right? This will be rotating slow, and which will be half of half of the speed. You know why? Because it has more number of teeth, so this will be rotating fast and this will be rotating slowly. And if you let's try to put in this formula, so in this case again you will be using t into r is equal to k. Since according to the question, this is as I said, like s into x is equal to 1 to z, which means this t into r is equal to k, which is constant. So this formula I'll be applying for this gear. So it has 10 number of teeth, speed we don't know, which is r, and k is as we calculated for this one, which is 5. So r is again half in this case, 5 by 10, which is half. So it is rotating at half revolutions per second, right? You're getting, I think. So yeah, this is right now like this one is right mostly rotating half revolution per second. So in this case your answer will be no. So this is not in the example, just to explain you I'm explaining like how to visualize. Okay, so let's say like I was telling, this has 5 teeth and this has 10 teeth. So like one teeth and one more teeth, it will be connected, right? So let's say it is rotating, it will be connected to one more teeth. So here only 5 teeth will be connecting, and this 5 teeth will be connected to this one, and in this 5 teeth it will rotate one revolution. And since you have 10 teeth here, so only 5 teeth are rotated in this case, which means only half the revolution that is done. So that is the meaning of this question. Let me try to take one more example and explain you. and this is T into R is equal to K, and T is inversely proportional to R, or you can write this also, R is inversely proportional to teeth, the number of revolutions that is inversely proportional to teeth. So in the first case it is yes. In the second case, let's try to use this example 6369. Yeah, we have 6369. 6369 we have, and here n is 4, which is number of gears are 4. 6369. Now since what they're saying is, try to understand, like let me arrange in this example this way: 6, 3, 9 and 6. Okay, or you can take one more example in this way: 6, 9, 3, 6 you can take. So what I'm trying to say is that if you arrange, let's say in this fashion, first one will be rotating at 1 revolutions per second. Now if you want to calculate its speed, this speed will be given by this will be previous teeth, how many teeth you have, present teeth what you have, which is 3, into previous speed, which is 1. And if you calculate this, it will be 2, right? Like 3 1 the 3 2 the. So this one, it is rotating at 2 revolutions per second. Okay, let me, I'll make you how to visualize this also. So let it be 2. Now this for this gear, if you want to calculate the speed, it will be you take previous teeth. So previous teeth is 3, current teeth is 9, into previous speed. Previous speed we are taking it as 2. Okay. So it will go 3 1s are 3 3s are. So this is rotating at 2/3 of the previous this one. Okay, so don't worry, I'll be telling you. And now let's try to consider this one speed. So previous teeth you have 9, current teeth you have 6, and previous speed is 2 by 3. So 9 2 is 18, 6 3 is 18. So all will be cancelled, and its speed is 1. So if you see, the leftmost you are making to rotate at 1 revolution per second, and rightmost is also rotating at 1. So now let me take these two gears and try to explain you. So first one, what we have is, you have 6 teeth: 1 2 3 4 5 6. Okay, the second gear, what we have, you have only 3 teeth: 1 2 and 3, let's say you have. So if you try to visualize, like 6 teeth you have, now this will all be connected. So when it is rotating, right, so if this teeth want to rotate one time completely, let's say this is a teeth uh, for this gear, and it will go in this, let's say, clockwise direction, and it will come here, which means this teeth will be crossing 6 teeths of this, right? Like you're getting, I think. So it will be connected to this one. Now since both are rotating and this is also rotating, so this will be connected to the 6 times, which means you have only 3 teeth, and this will be connected to the 6th teeth when it is coming here. So in order to connect 6 teeth, this will be rotating 2 times. If this teeth rotates one time, it will be touching the only 3 teeth. This will be touching only 3 teeth, and one more time if it rotates, this will be touching 6 teeth. So basically when it rotates one time, and this has lesser number of teeth, so this one will be rotating more number of times, like 2 times it will be rotating. So that is the reason here it is rotating at 1 revolutions per second, and it is rotating at 2 revolutions per second. Now relative to these two, if you consider, let's say its speed is 1, and this speed will be 1/3, because this one is relation to relative to this speed, so it is 2, and these two, if you see, it is like 2 by 3, 2 and 2 by 3, and if you divide it by 2, you are getting 1 by 3. So these two are like only 3 teeth are there, like 3 teeth are there, and here you have 9 teeth: 1 2 3 4 6 7 8 9. So this will be rotating, let's say if it rotating one times, it will cover 3 teeth of this, which means this has 9 teeth, so only 1/3 of the rotation it will be revolving. So that is the meaning of these things, right? Now So I think you guys are getting how to do this. So when you understand these things, right, like this one is rotating at 1 revolutions, so it's if you see number of teeth, it has lesser, right? So it will be rotating more fast, so that is rotating 2 times. And if you compare this teeth with this one, now since all are connected, right, so it will be relative. So this will be rotating at, since this is 1, and if you take with this one, it will be like 6 by 9 into 1, so it will be rotating 2/3 of time. uh, I think, yeah, 2 divided by 9, it is 1. So it is like it will be connected 6 thieves, and you have out of 6 thieves, you only 9 thieves will be rotated. Sorry, out of 9 thieves, only 6 thieves will be touching when it is rotating 1 time. So which means it is rotating only 2/3 of its revolution. So in the same way, so relative to this one, since both have same number of thieves, its speed will be same only. I think you guys are getting. So in this case, the main thing of the problem is that if you find the gears which are having, at least two same numbers, two same teeth, so those can be placed at the left hand and right hand, and those two teeth will be rotating at same speed. So that was it of this problem. So yeah, now third example what they had given is that they have given n is equal to 2, and the gears are having 2 teeth and 3 teeth. So in this case, if you see, they don't have equal teeth. So if they don't have equal teeth, this in this case your answer is no, and I'll prove you also. Let's say this one, this is the arrangement that you're doing. This is rotating at 1 speed. Now its speed will be given by the previous teeth, current teeth into previous speed 1. So it is rotating at 2/3. So last one is not rotating at 1 speed, 1 revolutions per second. So in this case, no is the answer. Let's try to take one more arrangement. So now here leftmost will be rotating at 1 revolution per second. Its speed will be given by the previous teeth, what you have, current teeth into the speed, previous speed. So it is rotating at 3 by 2 times. So again, if you say like it is not rotating at 1 revolutions per second, it is not. So in this case, you return no. So the main crux of the problem is that if you find any integer having same number, at least one integer, so in that case, that I mean same integers you can place at the leftmost and at the rightmost. So whenever it is rotating 1 revolution per second, the rightmost also will be rotating, because since they are connected, so according to physics also and according to this problem also, they have given number of teeth into its revolution will be some constant k. So that was it. Now in this case also, if you see, you have 10 10 3 times. So 110 you can place leftmost side, one more time you can place rightmost side, and those two will be rotating at the same speed. And you can make one arrangement in such a way that 110 is at leftmost side, 110 is at rightmost side, and you can do according to the given example. This formula, if you apply, you will be getting yes in this case. So that was the main intention of the problem. Let's try to code it up. So in the contest I use unordered map, but in this case I'll be using unordered set. So basically the first line will contain integer t denoting number of test cases, second line will have n number of gears, and third line will have n gears having teeth ai, b, a1, a2 up to zone an. So we have set here, let me take one temporary variable. I'll be running a loop till n, and I'll be taking the value into this temporary variable, and this I'll be inserting into set. So whenever if you see in this case, we have two elements, and both the elements have unique elements 2 and 3. So in the set it is having 2 comma 3 and its size is 2 only. If all the elements are unique, then the set size will be equals to n, right? So what you will have to find is if set size is less than n, which means you have at least one integer which has repeated. So in that case, you are able to make the rightmost gear to rotate it 1 revolutions per second. uh, in order to do that, what we'll be doing is we'll be basically taking the same integer, let's say 10 comma 10 or 5 comma 5 or 6 comma 6. So that will be placing at the leftmost side and rightmost side. So in this case, you'll have to return yes, sorry, you'll have to output, else you'll have to output no. Let's try to run it. Yeah, it got passed. Let's try to submit it. So it's problem, I think we can't submit it right now, but I had done the same example. So as you can see, it is accepted. So you guys can test this code and try to submit them, and it will be working fine. So it was more of constant, like t into r is equal to some constant. Basically, a gear having more number of teeth will be rotating slowly, and a gear having less number of teeth will be rotating fast. So basically, that the number of teeth into the revolution speed is constant. So that was told here at this point. This is the formula. So from this you could have figured it out, and once you figured that out, so you knew that like if there are two gears having same number of teeth, so those speed will be constant because all the connected components have t into r is constant, as I showed in the board. So last gear will have the same speed as the leftmost if it has two, I mean at least one gear having same number of teeth. So in this way you could have solved the problem. Thank you guys for watching the video.